Good morning, everyone. And we're going to be, my name is Mahesh Srinivasan. I'm a VP in our smart sensing and display group at Synaptics. And I'm here to talk about a new product that we are launching specifically for the IoT human machine interface segment called FlexSense. A quick walk down the memory lane of Synaptics that I wanted to present. Most of you know Synaptics. We started in mid-80s. We started actually as a neural network processor company and sort of then delved into capacitive touch sensing solutions for PC, mobile phones, tablets, automotives. But in the early 2010s, we also invested in some video and audio and multimedia products. This was prior to this term IoT was coined, actually. And more recently, we have invested a lot in connectivity solutions as well as AI solutions. So we have gone from a capacitive touching, started off with neural network processor, and finally we have landed at come a full cycle back to an AI solutions right now. So please do visit us. We are in booth just down below here. So the three pillars of Synaptics, as we would like to call it, we would like to call it as human-machine interface. That's where all our sensing solutions fall into. IoT, which is predominantly connectivity, and then AI, which is the new segment that we are getting into in terms of edge AI solutions. I mean, what I am talking about here today falls within the HMI pillar of Synaptics. Okay. That was a bit of a marketing pitch out here. So going back to the product we are launching, when we talk about IoT devices and user interaction and HMI, it's really hard not to talk about this particular device. By this, what I mean is a smartphone. So coincidentally, it was today, 15 years ago, when Apple launched their first iPhone. And that really transformed the way consumers use a capacitive touchscreen to interact with devices, right? In terms of responsiveness, in terms of just intuitiveness, it radicalized the world. Now, fast forward that to this IoT segment, consumers expect that same kind of intuitive interactive experience. The big difference being, when you're using this device, you're actually looking at it right in front of you. That's not the case with most of the IoT devices. And then look at it from a form factor perspective. Most of the phones follow a very similar form factor. Whether you're using an Android phone or an iPhone, you pinch to zoom. So they're very similar user experiences. But the problem with the IoT devices is they're extremely diverse, and the way you interact with are very different depending on what device you're using. And to provide that intuitive, immersive user experience today across IoT, you need different discrete sensors sort of mixed together to bring that experience back. And that's essentially the crux of the problem we are trying to address with FlexSense. For example, on a gaming controller, if you want to distinguish between a user interaction and a user intent, you'll need two discrete sensors, one for handling capacitive touch and one for handling force. And these devices need to be context aware so that they can actually distinguish between a real event and a mistouch event. And those require discrete sensors today. And that's essentially what we are trying to address with FlexSense. I have some slides on some use cases, which I'm not going to go through every single slide here. But if you look at these interactions across these smart home devices, they offer gestures to interact with them. You can also talk to them. They are also aware of the context. For example, they are aware when you're actually gripping them in your hand, so they can dynamically switch contexts and provide a good user experience through wireless buds. That's a classic case because these devices know, for example, when they are docked in a case, or when they are lying on a table, or when they are inside your ear, and they are able to sort of adjust based on that context to provide a better user experience. Now, forwarding it to just a summary of market requirements here, right? These market requirements require multiple sensors to be used. They all demand very small form factors. If you look at this diversity from a smart home device to a tiny little TWS, you need to have a small form factor to be able to fit into these devices. And low power, it's a standard requirement. Most of these devices require or operated on battery. Durability and reliability are absolutely important. These devices You need to be able to use these devices while you're working out. I've seen some avid gamers who are playing so fast with their gaming controller with a cup of coffee and spilling it on the gaming controller. So these devices need to work in those rugged, reliable conditions. And last but not the least, cost, time to market are extremely critical. So these are the requirements that we took into consideration while launching FlexSense. So in short, a one-line definition of FlexSense is it replaces multiple discrete sensors with a single tiny, ultra-low power and highly configurable processor. And I want to stress on the word configurability, because that IoT, when we say IoT edge device, you're talking about million kinds of devices here. So for us, really, that configurability and flexibility, especially to handle HMI, was really, really important for us. Very tiny form factor. It's 1.62 by 1.62. We offer both wafer level CSP as well as QFN packages. It comes with a proprietary optimized multi-sensor processing engine that's sort of optimized for this edge IoT market. I've been talking about sensors, so the kind of sensing schemes we support capacitive sensing, inductive sensing, as well as Hall effect sensing. Now, the capacitive sensing is used for proximity or sort of a grip detection or an in-ear detection, as well as like simple user interactions like touch, tap, sliders. Inductive sensing is used as a way to measure the force, and that's typically used to know what the intent of the user is. For example, how hard are you pressing on your gaming controller? That's addressed using inductive sensing. And we do have a Hall sensor on the die that's used typically for like dock detection. Is the buds in the case or not? And the product offers up to 8 channels. And the nice thing is these channels are completely configurable based on the product you are designing. Now, if you need a 4-channel slider and a single channel for inductive sensing, you could do that. You could also use the product for a complete set of capacitive buttons only application as well. So it's fairly configurable within this 8-channel segment that we offer. And this is again a very, very diverse market. So we do offer a configurable set of tools that make it easy to go from prototyping to mass production as quickly as possible. And a typical TWS, true wireless headset use case, we believe that we would reduce the total BOM by about 80%. This is replacing the multiple sensors today with our one single solution. So this is sort of the high level. To talk a little bit behind the screen on how we really accomplish this, we have a proprietary optimized analog hardware engine that supports a wide range of sensing inputs, whether it's capacitive, inductive, Hall effect, and it's essentially designed and architected for removing the noise as quickly as possible and at low power as possible. And we do have a piece of firmware running on our digital microcontroller, but it's a very simple, lightweight microcontroller. And the primary goal of the firmware is essentially to do this context switching of the sensing schemes so that we can maintain an optimal power consumption. And to give you an example, this is, you want to know the firmware knows that the device is docked inside or in your ear, and it can dynamically switch those states. It turns off channels on and off to maintain an optimal power consumption, both in technical terms, both in a deep sleep state, and people call it with different terms here, deep sleep, doze state, or when you're in sort of an active mode of a device. The other thing that's done in the microcontroller is environment calibration. And for folks who have been involved in capacitive sensing, you guys should know that there's always that environment impacts, whether it's temperature, wetness, moisture, humidity. So you sort of need to adjust what we call as our baseline signals to match with their environmental drifts. So there's a small little algorithm that runs inside. And The main functionality is it analyzes all these sensor inputs and the firmware makes a decision. Did the user swipe on the TWS? Did the user push a button? And that's the decision it makes. And we have a single I2C connection to the host to report that final output. And it's really hard not to talk about AI when we talk about IoT. I mean, this is not an AI processor. This is really a multi-sensor processing engine. But what we also know is we have designed and structured our firmware in such a way that we can feed that data, whether it's good, clean data at low latency possible, to another adjacent AI processing engine. And that's how we built it. And for AI to work well, you need data, you need clean data, and you need fast data. And that's how we have designed it here. So we expect in the future FlexSense to be part of a bigger AI ecosystem, where actually this feeds the data into our AI processor to make more sort of intelligent decisions. So to summarize this, our entire goal really is, we want to bridge this gap between HMI and IoT. And our configurable architecture addresses this diverse sensor technology requirement for IoT. You're not dealing with one flat touch screen here that just offers a capacitive touch interface. You're dealing with like millions of combinations of sensors and low power and footprint. You need the right trade-off between responsiveness and reliability. And for folks who are aware of capacitive sensing, there's one thing that I want to say. One reason why capacitive sensing took off in the mobile phone world is that it's super responsive. You get to see the reaction as soon as you put your finger on the screen. And that, in a nutshell, is actually the disadvantage. Because it is super responsive, it's also sort of by design prone to mistriggers or mistouches, as we call it. So the way we have designed our product is to have that right trade-off between reliability as well as responsiveness. And the beauty of this is it's actually configurable based on the design and the requirements of the product. So that's all I have here for today. We're actually back in that booth 1032 right behind us, so feel free to visit us. We also have booths on our connectivity solutions as well as our low power AI, which would be great if you guys can check out all those products as well.